Hello and welcome to this course, Machine Learning for Stocks using Python. My name is Victor and I am part of the Genbox trading team. We are a company with a team formed by mathematicians, traders and computer scientists with a sole purpose. We help traders make consistent returns on the market using artificial intelligence. And in this course, we are going to do an entry-level hands-on project. The strategies presented here are going to be simple yet functional and robust. This course is oriented for both traders and coders who want to learn about machine learning techniques for time series analysis and forecasting. And the objective of this course is going to learn how to build a machine learning model, how to validate it, and use it for forecasting stock returns. So before we start, this platform is going to ask you for a review way sooner than later. Keep in mind that most of your questions are going to be solved further on this course. If you like this course and want to see more, of course, feel free to rate it with 5 stars. We hope you enjoy it, and please check out our other free courses also on this platform. Model. Before rolling up our sleeves and start working on our model, we need to understand first two things. First of all, the steps that we are going to perform, anything from data acquisition to make forecasts, and also how neural networks work. So, our model is going to be based on 6 simple steps. First of all, we are going to acquire historical data in order to feed it to our model. We are going to use that data to create technical analysis indicators. This way, we are going to be creating useful insights in order to analyze the market. Later on, we are going to label our data because we need to tell our model what to look for. Finally, we are going to create our model, in this case a neural network, and later on we are going to perform a backtest in order to understand if our model is valid and robust. And finally, we are going to use this model to forecast some stocks. First step is going to get some historical data to train a model. We are going to be using Yahoo Finance and stocks data to automatically download our data into our Python script containing our model. Before we create that model, we are going to create some useful insights in order to make a forecast. The commonly used data on machine learning models can be either fundamental data, sentiment analysis, or technical analysis. On this course, we are going to be sticking to technical analysis data. Then we are going to classify that data in order to tell our model what to look for. This is what's called supervised learning. The algorithms won't know the possible outcomes until we define them, and in this case we are going to be sticking to something simple. We are going to be having data, in this case technical analysis indicators. Our labels are going to be binary. The stock price can either go up the next day or go down, and that's what we are going to feed our model. We are going to have the current data and the next day return as our label. Once we have all of that done, we are going to be adding a neural network. But first, what are neural networks? Neural networks are a family of algorithms that recognize underlying relationships in a set of data. Said in another way, neural networks are algorithms that are going to help us recognize patterns in a given set of data. And they are called this way because they tend to resemble the connections of neurons as synapses found in the brain. A neural network at the end of the day is going to be looking something like this. So neural networks have 3 layers. We are going to be using simple ones, that means multi-layer perceptor neural networks that look something like this, and they are divided in 3 layers. First of all, have the input layer. This is the first one, and on this layer we are going to be feeding all the data we want to analyze with our model to analyze it, in this case, on the hidden layer. This layer is going to be managing the input data and processing it. This means For each input data that we want to add, each row, each column that we want to analyze, it's going to be propagated on the hidden layer and mixed with all of the other data, and it's going to be setting and creating some different weights and different formulations in order to create a formula for the output layer. That is the forecast that we want to use. Once we have our data fully prepared, we are going to be feeding into the model. The reason that we are going to be sticking in this course for neural networks is that they tend to be, first of all, simple and robust for trading. Finally, we are going to be backtesting our model to determine if it is valid or not. So we are going to test its performance and various metrics to understand its properties. Final model is going to look something like this. In this case, we have the strategy of returns and the evolution of $1,000 over the years using this model and trading it. Finally, once we have our model backtested, we are going to create a forecast of Apple's stock price for tomorrow. And we are going to see if our price is going to be going up or going down. So that's all the theory that we are going to see on this course. And now, yes, it's time to roll up our sleeves, get our hands dirty, and start coding. So let's get to it. So first of all, what we want to do is head over to Google Collaboratory, that is collab.research.google.com, because we are going to be executing our model in the cloud. This way we don't need to install anything on our computer. So I'm already here and I'm going to be creating a new notebook. I'm going to assign our notebook a name, in this case, machine learning for stocks, and that's it. Now we have an IDE on the cloud and we can start coding here, and whatever we code, we can execute it. So you can see once you hit play, you have everything working on. Alright, so there we have it, we have our first hello world. So now it's time to start creating our model. First of all, for each step, for each module, what we are going to do is to create a text module over here. And first of all, we are going to be defining what we are going to do. So first things first, we are going to create a title. We are going to use a header to sizing here and machine learning for stocks trading, and we close that tag. H2. The first step, it's going to be getting some historical data. Alright, what do we need to get historical data? We are going to be using what's called libraries or modules. We are going to use, first of all, the Yahoo Finance module. This way, if you have seen some of our other courses, you know that we download our historical data on the Yahoo Finance website. In this case, since we are going to be coding, we are going to download it automatically from here instead of going to the website, selecting the stock that we want, going to the historical data tab, selecting the data range. Alright, so nothing like that. We are going to be using the Yahoo Finance module. We also want to create charts. Once we have our stock downloaded, we are going to chart it or plot it, at least the closing price, to see that everything's going to be fine. We are going to also need to handle data frames. We are going to be using a library called pandas. And finally, we need data functions. So we have everything, every requirement posted here. So we are going to create a piece of code. This first step is going to seem probably one of the hardest, but in this case it's just a matter of memorizing what libraries we need to use. So I'm going to import first pandas, import pandas as PD. This library is going to let us save our stock prices and data as a data frame. This is very useful and convenient, as we are going to see later. Second of all, import matplotlib.pyplot as PLT. This is going to let us create some interesting charts. Also, we are going to import datetime, and from datetime we are going to import date and time delta. This way we are going to be managing the start and end range for our stocks historical data. Finally, I'm going to set a comment here. Install the Yahoo Finance libraries. These libraries are not by default installed on Google Collaboratories, so we are going to be installing ourselves. What we want to do is, first of all, we are going to create a try module, and we are going to try to import it, because if we have already installed, because we are going to be executing our code once and again and again and again, at some point we are going to be having installed. So if that's the case, import Yahoo Finance. And there is an exception for that. Try to import Yahoo Finance, but if we don't have it, we are going to put an exclamation sign pip install -q Yahoo Finance. And once that we have installed, now you can import it once and for all. And we are going to do the same with try import Yahoo Financials with an exception. Try to do it, but if we don't have it, pip install -q, that is minus quiet mode, Yahoo Financials. And then import Yahoo Financials. Alright. Now that we have it installed, we are going to write something like import Yahoo Finance as YF, and from Yahoo Financials import Yahoo Financials, but with capital letters. Finally, we are going to add here import warnings, and we want to ignore all warnings of deprecated code. In this case, we are going to be facing that this Yahoo Finance library, while it works, it can also throw out some warning signs, but none of them are important in this case. It's just about deprecated code, but hey, it still works, so we can use it. Alright, so let's check out our code. We are going to be importing pandas, matplotlib, datetime, Yahoo Finance, Yahoo Financials, and we are going to be ignoring every warning. So I think that's all. I think I didn't forget anything. We are going to download our historical data, and you're going to be seeing that this is a pretty simple and straightforward process. So df, that's short for data frame, and it's where we are going to store our historical data, equals to yf.download. We are going to be opening a parenthesis here. First of all, we are going to be selecting our stock ticker. I'm going to keep it simple, keep it short. Apple, AAPL, all in capital letters, comma, and we are going to hit enter. The start date, it's going to be 2010-01-01. Why? Because we want always, when we are using machine learning, to analyze at least 10 years of historical data, but never more than 15 years. less data than 10 years, we are going to have an overfit model because we have so few scenarios that whatever we analyze, it's going to be always the same. Once the market regime changes, our model is going to be stop working. If we have something more than 15 years of historical data, we are going to have so many scenarios that our model is going to be underfitted and its returns and performance is not going to be working fine. So start data, excuse me. So I see, all right, now that we have it done, we are going to add another comma, we are going to hit enter, and we are going to be setting our end date. In this case, date.today and a parenthesis here. This way we are going to be always finishing downloading our data as soon as we have all of it without the needing of setting our code and our date each day. Finally, progress equals to false. We don't need to have a progress bar over here or anything like that. And now that we have our historical data, we are going to create a very simple chart. All right, so we put df. Remember, this is our data frame where we have downloaded our data, point, plot, and the y-axis is going to be the closing price, and the title of our chart is going to be the Apple stock. Finally, plt, short for plot, dot show, and parentheses, open and close. And we are going to press play on our code. If you have written everything of this right, first of all, as you can see, we are downloading Yahoo Finance and Yahoo Financials. We are going to have a simple warning despite we have ignored it. This isn't any problem. And if you have done everything of this right, you are going to see this very simple chart. So, all right, step 1 is already done. We have our historical data, so let's move on to the next step. Alright, so now that we have our historical data downloaded and plotted, we are going to create a new text module, and we are going to be creating the technical analysis indicators, and we are going to also plot them. Perfect. New code module, and what we are going to be is importing a new library, in this case try import pandas underscore ta as ta. Pandas technical analysis library. This library is going to let us create or call basically any technical analysis indicator without needing to use any formula, and in this case it's the same as Yahoo Financials. It's not preloaded on Google Collaboratory, but we can install it anyway. So, except pip install -quiet pandas ta, and then we are going to be importing pandas underscore ta as ta. Now that we have our library, it's time to create our indicators. We are going to be creating inside of our data frame. So first indicator that we are going to be doing is an RSI of 2 periods. So we call inside of our data frame, we are going to be creating a new column that is called RSI, and between parentheses 2 TA, technical analysis. Remember, this is our new library, point or dot RSI, parentheses, the closing price first, df, close, and comma, length equals to 2. Then we are going to be creating a couple more RSIs, for example, RSI 7 period. And we are going to be doing the same, ti dot RSI df close, but instead of having a length of 2, we are going to be having a length of 7. Finally, TF RSI 14 period equals to TA.RSI data frame close, comma, length of 14. Also, we are going to use CCI, a commodity channel index indicator, CCI of, let's say, for instance, 30 periods equals to technical analysis dot CCI. The closing price is going to be DF close, comma, the length of our indicator is going to be 30, comma, the high price is going to be DF high, and the low price, comma, is going to be DF low. This indicator needs first closing price, length, high, and low. So since we need different prices for calculation, we are going to determine what price is each one. The closing price is this one, the high price is this one, the low price is this one. We are going to now copy our CCI and we are going to create more periods. For example, CCI 50 and CCI 100. And we are going to be changing the length. So we have our technical analysis indicators. We have 6 of them. If you want more information about this library, you can find it on Google, because you can see how to call over 100 indicators and counting, because each day the developers of this library are creating more and more indicators. Perfect. So what we want to do now is drop the name values. These values, stay with me here, are values that basically are 0 or non-computable values, because if we want to analyze, for instance, the CCI 100 periods, we are going to need first 100 candlesticks. So if we don't have those 100 candlesticks, we can't calculate our indicators, and we are going to have basically an empty row or an empty column in this case for the first 100 values. So our data frame is going to be equal to, hold on a minute, all right, equal to data frame dot drop NA values. This way we are going to be having a clean data frame that we are going to be able to use. And finally, what we are going to do is to create plot showing some of our indicators. df.plot, the y-axis is going to be the, for example, the RSI 2 period, and we are going to be creating another plot that's going to be, for instance, the CCA 100 period. So we can see the differences between the 2 period indicator and a 100 period indicator. And finally, we are going to check out how's our current data frame going. df.head. And we are going to be hitting play. We are going to, as you can see how Pandas TA is installing. First of all, our RSI 2 period, CCI 100, these are both of our indicators. As you can see, each one is calculating over this stock price. And on our data frame, we can see now that we have our historical data, date, OHLC, open, high, low, close, our adjust closing price, accounting for splits, volume, and now that we have our useful insights or useful information. We have our 2 period RSI, 7, 14, 30 period CCI, 50, and 100 periods. So we have our prices and our technical indicators. So it's time to move to the next step. Now that we have our historical data prepared and our indicators, we are going to create a new text module, and we are going to prepare our data labeling. And what do we want to do over here? All right, so when we are going to place our trade, we are going to buy at open. We are going to be always buying at market open. This means over the next day. We have today's data, we are going to perform our forecast, and we are going to be buying the next day open. And we want to close our trade at the next day at open. So in a formula, a very simple one, we are going to be handling the returns this way. Open -1, this is the next day, all right? We are going to be buying here, and we are going to be closing at open -2. Since we want to label our data on the following way, we are going to have a buy signal if the open -2, this is where we are going to be closing our trade, is greater than the open -1. And we are going to have a sell signal or a short selling signal if open -2, the closing price is lower than the price when we open the trade. So as you can see, we have indicators that represent the current situation, and our labels take a look ahead of time to determine if the data that we have is going to be creating a pattern. If we have a pattern. So, time to put that into a piece of code. First of all, we are going to be importing NumPy. NumPy is a library that is going to let us handle anything related to numbers, to calculations. And we want to create a new piece of our new column or data frame that is going to be called label. Our label is going to be consisting of a numpy.where. This is some kind of a if statement. If certain conditions is true, we are going to set the determined value. If not, we are going to set another value. So numpy where our date frame open price shift -2, this is where we are going to be closing our trade, dot is greater than dot gt. We are going to be opening another parenthesis, df open price of shift -1. All right, so if this condition is true, we are going to be setting our label as 1. This means if our closing price is greater than the opening price, we have a positive outcome, it's going to be a 1. But if we don't have that positive outcome, it's going to be a 0. Because we want to classify, in this case, what outcome we want to buy or trade. And we are going to be using for this course a bullish bias, a buying bias. So df equals to df.drop NA. We are going to get rid of name values, and finally df.head to show us our date frame. So we are going to see now what happens on each row. First of all, label 1. These indicators are forecasting or are telling us that these values are going to give us a winning trade. So we are going to be opening our trade at 8.95 and we are going to be closing it at 9.26. That's correct. Next one, we are going to be opening our trade at 9.26 and we are going to be closing it at 9.27. So that's correct as it is. And now we have all of the data labeled, so we are going to head over the next step. So for our next step, we are going to be creating a neural network. And in order to do that, we are going to be using scikit-learn, or sklearn for short, in order to call our model. So let's go to our code cell and start writing code. Import sklearn, and now we need to import each individual dependency that we need to work with. In this case, from sklearn dot neural underscore network, import MLP classifier. This is going to be one of the core libraries that we are going to use for our MLP multi-layer perceptron. Sorry, I have a typo over here, network. All right. From sklearn dot neural underscore network, import MLP regressor. From sklearn dot model underscore selection, import train test split. This is going to allow us to separate our data into a train set and a test set, because first of all, we are going to be training a model, but we want to leave a piece of data untouched to verify if our model still works fine or if we have overfit our model. Then from sklearn.metrics, we are going to be importing the mean squared error. This way we are going to know how our metrics are working and how accurate our model is. From mathematics or math, we are going to be importing the square root. We are going to use that for our calculations. And finally, from sklearn.metrics, we are going to be importing the R2 score. Alright, so we have our libraries imported. What we want to do now is prepare what we are going to be fitting to the model. And we are going to be fitting basically two types of data. Our indicators, or one instance, and our labeling. So in the x-axis, we are going to call our data frame indicators. df.columns, and we want to fit, in this case, we don't want to fit the column 0, neither 1, 2, 3, 4, 5, or 6. So we want to start with the RSI2. In this case, it's going to start in 6, or after 6, excuse me, because date isn't counted here, since while we are using Yahoo Financials, the date is already set as an index and not a column. So we are going to be starting from the column 6 until the last one. We want to import everything from here until not the last one, but the one before that. In this case, we are going to be importing as indicators from RSI2 up to CCI 100. And if we add more indicators here later, it's going to be always the same from the first indicator until the last indicator. All right, point values. And for our y-axis, or the labeling axis, we are going to df label dot values. Now we are going to be splitting our testing data and training data. In order to do that, we are going to create some variables. First of all, xtrain, comma, xtest, comma, ytrain, comma, ytest. It's going to be equal to train test split. This is the function that we have imported from the sklearn model selection. And parenthesize x and y, we are going to be dividing, or better said, we are going to be splitting the x-axis and the y-axis into these variables, and we are going to test size. We are going to be reserving 30% of our data to test. Alright, so we have that done. We are going to create now our neural network. MLP equals to MLP classifier parentheses, hidden layer sizes. First of all, we are going to be defining the size of our hidden layer. If you remember correctly, we have 3 layers, the input, hidden, and output layer. We are going to create 3 layers of a size of 8 each one. We are going to set an activation formula. In this case, we could use various formulas, but we are going to keep with the standard, the prelude, and a solver or optimization process using ADAM. And we are going to set a number of iterations of 1000. So we are going to be training our model 1000 times, and we are going to feed our model with some data. MLP feed, parentheses, xtrain, those are going to be our indicators, and we are going to be comparing it to ytrain, our labeling. Finally, we are going to save the predictions. Predict train equals to MLP predict xtrain, sorry about that, and predict from test data equals to MLP predict xtest. So what have we done here is basically we have first of all imported all that we needed from sklearn. We have prepared our data, our indicators and labeling. We have split between train and test data. We have over here our neural network created with some basic standard parameters. And finally, we have fitted first of all that neural network, we have trained it, and we have over here what are our training predictions and testing data predictions. So what we are going to do now is importing one final module that is going to be sklearn.metrics import classification reports and comma confusion matrix. And we are going to print a classification report consisting of ytrain and predict train. This is going to be our in-sample data. We are going to hit play. Sorry, I missed a parenthesis over here. We need to close our print. Now we are going to hit play once again. And there we have it. We have our model, and over here we have the accuracy of our trained data in this case. And we can see that for any prediction that's labeled as 1, have a 57% accuracy ratio. This is very good. And for our bearish markets or bearish days when the markets are going down, we have a 52%. Okay, that's great. We are going to add over here print between, and we are going to create something like train data. And now what we are going to do is do this something the same, very similar to our testing data accuracy. I'm going to use the same format over here. All right, and we are going to be printing classification report of ytest and predict test. And if I have done everything all right, we are going to see over here that have our 57% accuracy on buying signals and a 55% accuracy on our testing data for our buying signals. So on every model, what we are going to see is always a steep decline between the train and testing data. We always want that the more similar they are, the less decline our testing data have. It's going to be better. And in the case for stocks, this kind of model that we are doing right now works fine for buying signals because we are following a trend. But short selling signals or bearish stage signals tend to have a lot of noise, a lot of unpredictable components or more harder to predict components, that is higher volatility and in some cases even macroeconomic events. We can predict that or create models for that in other courses, but as you can see, this is why we are going to be sticking for buying signals. They are easier to predict and easier to trade. And as we can see, in both cases are over 50%, so it's beating randomness to some extent. So right now, in the next step, what we are going to do is be backtesting our model. So now that we have our model, we are going to be adding a new text cell and we are going to be backtesting our model. What we want to do over here is basically measure the returns obtained by trading our model. Alright, so new code cell, and basically what we are going to do is add first of all into our date frame the prediction values, right? Date frame predictions, and this is basically we are going to call numpy, and we are going to be appending over here the series of prediction in training and predict test. So we are going to have the predictions for all our time frame or time period, and we are going to create now in our date frame our strategy returns. These returns are basically a measurement of all the buying signals and what happened on the market if we bought the next day and sell after 1 day passes. So numpy.where our df prediction equals to 1, we are going to, if our prediction equals to 1, we are going to create the returns. We are going to be closing open shift -2 minus df open dot shift -1. And if we don't have a prediction over here, what we are going to do is set that trade as a 0. It's neither winning or either losing. Finally, we are going to add df strategy returns equals to df strategy returns dot constant. We are going to be adding each return to its previous value so we can have over the time a compounded time series. Finally, df.plot y strategy returns. And finally plt.plot. We are going to play our piece of code and we have over here our strategy returns. In this case we have measured as US dollars for each stock or for one stock trade, each one. We are going to be trading one stock. And finally what we want to do is create a prediction for the next trading session that is going to take place in a couple of hours. So we are going to be isolating our current prediction. This is the last one that we are going to have on our data frame. df.ilog -1, this is the last row that we are going to have, and we want to fetch from here the prediction. Now, if our prediction equals to 1, this means that we can print something like today's return forecast is going to be up, and we could add an else statement. If our prediction isn't 1, we can print something like today's return forecast is going to be down, and we are going to hit play. Alright, so our forecast for today using this model is going to be down, so I don't want to trade Apple today. Now that we have all of our code done, we can test, in this case, what happens for other stocks. For example, we could be trying to trade Tesla, and we are going to hit play. As you can see, we are not going to be downloading our libraries once again, since we have it already downloaded, and we can create our technical analysis indicators. We have them over here. We are going to be preparing our labels. We are going to be creating our neural network. As you can see, the ratios in this case have changed. Now we have 57% against 53%. It's okay. We are going to be backtesting our model. In this case, we can see that our model is going to be way more volatile. If you don't like your current model, keep in mind that you can retrain it once again until you have a model that you like and you want to trade. Okay, we have another model here, or in this case, excuse me, if we want to retrain our model, we have to go back, but I'm going to give you a piece of advice. Runtime, run all. Now, you are going to be waiting, okay, 55% against 52%. This model is way more volatile, so once again, we are going to run our script, 54 versus 51, but this model looks way better. And today's return forecast for Tesla is going to be up. So that's all for this course. We hope you enjoy it. And if you want to learn more, visit us at gemboxtrading.com. And I will see you around in other courses.